Okay, so we are seeing areas now. Okay, so we know that the area under a curve here, y equals fx from A to B is this, okay? This is area under the curve, where f is bigger than or equal to 0. You can see it here, okay? So this is gt f dash t. So these are the intervals. This is the A and B boundaries here. So you can see it here. There's a shape here like this. So here 0, 0, the point is 0, 0. The point is 2pr. X is 2pr and y is 0 here in this part. So we can have an x equation. So let us talk about equations again. So I'm going to open a new page for this one. I will say this one later and make it smaller. Okay, that's better way now. Okay, so here this x is a function of r here. Okay, sorry. X is a function of r, so I can write it like this. This is small x. Okay, x is a function of r, and it equals to r. Okay. Here, this is theta. Theta is here. This wait, not from here. Okay, this theta minus sinus theta. Okay, so this x is a function of r in terms of r. It is a trigonometric function, as you can see, and we have a function y in terms of r again. As we said before, they simply refer it as x, okay, but we know that this is a function of r, so we write it like this. And this is a function of y. Write it like this here. This is r, 1 minus cosinus theta. Theta is here. 1 minus cosinus theta. Good. Okay, this is a function in terms of r. This is a y in function in terms of r. Good. So let us continue with the next slide. Here, these are the boundaries. We know that this theta can be between 0 and 2p. Okay, it's a complete wall here, 2p. Using the substitution rule, yeah, so here we are going to use the substitution rule for this y here, and we find derivative of x according to theta, here derivative of x. We are going to find the area under this curve. Our aim is to find area under this curve. So this is the formula, okay? So when they ask us what is the area under this curve, we take integral, okay? In order to find slope, tangent line, we take derivative. But to find the area, we always take integral. Okay, so here the area here is this formula. Okay, so the area is always the integral. Okay, integral of this y here. Okay, y according to x. This is the formula for all curves, for finding all curves under area under all curves. So the upper boundary is 2pr, okay, it's 2pr. It's 2pr, and lower boundary is 0. Here, the lower boundary is 0. From here, let me choose this one. Okay, so lower boundary here. Okay, 0. This is the upper boundary. 2pr once again. is lower. This is 0 and this is 2pr. Okay, so this is the area under integral. So what's happening there? Ferhat and Sadat. Okay. Do you have a question? This is the area under the curve. It's integral of y dx. Okay. So here this y. What is y? Y is r1, this one. Okay. And here you can see that this y, in order to find this y, okay, y was this, okay, r minus cosinus x. We write it also here. This is r1 minus cosinus x. This is r1 minus cosinus x. But we need to find dx, okay? So we have to find derivative of this one, okay? And you see here, we have this r here. So I can copy this, okay, here. I'm going to find integral, okay, I can copy this one also, wait, okay, I'm going to delete the first part, yes, okay, so here, this integral, okay, this is y, this part is y, what you see here is only y, okay, what you see here is only y, but we need to have this dx here. I have to find this dx. In order to find dx, I have to take derivative of this one, okay? And I have to take derivative of both sides. So it will be dx equals to here this one, okay? By the way, let me check what is x here. What is x? X is, yes, theta, sinus theta, okay. So here, okay. So here I check what is it as here to find the derivative. Here, if we want to find derivative according to d theta, we find that dx equals to this one, okay. So derivative dx over d theta, we here in fact we are finding. This is dx over d theta. We are finding derivative according to theta, dx over d theta. This is d theta here. This one. Okay, it equals to r. Okay, you can see that derivative of this one is 1. Okay, and derivative of sinus theta is cosinus theta, so I write cosinus theta. Yes, I write it cosinus theta. Okay, and this is the derivative of x according to theta. Okay, what I do here, the equation gave me, okay, from beginning. Here is the equation, okay. It gave me two formulas. This is the question. It will be given to you in your examinations also. So it wants you to find the area under this arch of the siloid. This is called siloid. And it wants us to find the area. In order to find the area, we have to find integral. And the question gave us x and y here. You can see the x and y here. Okay, so in this part, I write xr equals to this one, and this is the I need to find integral. As I said, I need to find the formula for finding area under this curve here, under this graph here, the arch here, is finding integral of it from with the boundaries of 0 and 2pr y dx. This is our formula. In this formula, we have y. And we find this y, this y is here, okay? This is written in terms of r, and it is expressed in the equation. It is only given in the equation. So I write this is y, which is given in the equation. Now I need to find dx, okay? I cannot just write here just dx. It's not true. I have to find what is dx. And in order to find dx, I have another function here. And the function says me that is in terms of r, okay? X is right in terms of r. And you can see that it's r theta minus sinus theta. And here, if I take this dx derivative of x according to theta, I find this one. Okay, so here, what is my next step? My next step is taking this theta to the other side of the equation. So I will have dx equals to this one here. I will have dx equal to this one, okay? Multiply by this d theta. It comes to here when I cross multiply. So this is multiplied by d. Okay, copy this also. This d theta. Okay, so this is dx. So instead of dx, which is at here, I have to write all this here. Instead of this dx, I have to write all this here. Okay, so this is y. Okay, this is y, and this is dx. So it is just the formula here. You have to know this by heart. Okay, whenever you want to find under area under a graph, is integral, and you have to know that you are going to take integral of y, which y stands for y-axis and x stands for x-axis, okay? And you have to make sure that you find what is y here in the questions is given, and we solve for dx here. Dx is this one, okay? So dx is this part. So if you continue solving this one, we see that we have 1 minus cosinus square theta, which is sinus square theta, okay? So from now on, I'm going to write equal sign here, okay? From now on, my question becomes this question. Okay, this equation becomes this r to the power 2, okay? If I multiply, there are two r's here, this becomes r to the multiply by 2, and okay, I put there, these are all multiplication, and you see that 1 minus cosinus square theta, you see that this is 1 minus cosinus square, okay, so in fact this is like this. This is more than that. It's not just 1 minus cosinus square theta. This is, let me open it here. It is in fact like this. 1 minus cosinus theta here. 1 minus cosinus theta, okay? And multiplied by 1 minus cosinus theta. Okay, this one here. Okay, this makes this over 2, this over 2, okay, this to the power 2, okay, and now be careful about that 1 minus cosinus to the square theta equals to sinus here square theta. Okay, so these are different. When we have, you know that when you open it, this is different. This becomes, let me continue from here. Okay, I can continue from here. Equal sign. This becomes 1. Yes. Nasıl? Yani görmüyor musunuz? Sesimi mi duymuyor musunuz?